right? As we discuss about the resolving forces, right? The advantage of resolve a force into two separate horizontal and vertical component is that in a system like in this diagram, right? Let's say, okay, like this. If I want to find the resultant force actually, right? Let's say this force is 20 newtons and this force, and here's another one, here's another one, there's another one. This has 5, this is 10, this is 20, this is another 5, and here we will take as 10 newtons. Now, in this kind of a question, they should always give us the, right? We can ignore the horizontal and vertical forces, but this, you can see this angular force, the 10 newtons, there should be an angle should be present here. Let's say 60 degrees, okay? Now, in this kind of a case, now I cannot directly find out the resultant force here, right? Because this is a force system. It is going to be an issue, okay? And I actually forgot to mention one force here. The weight of the object, let's say it is also 20 newtons, right? 25. Okay, let's find out the resultant force, okay? And I cannot find out the singular F now. Okay. Now you can obviously see this 10 Newton force has to be resolved into two components, right? The angle is 60 degrees. And when in the angle side component, right, you can see the angle is given with the x-axis, which means the horizontal component and the force. So this has to be what? 10 cos 60, right? 10 cos 60. And you can find out these values using the trigonometric this value table actually, right? Or in the calculators, you can see 10 cos 60, you can directly get the value, right? I'll find out the value for you. Cos 60 value is 0.5, okay? Cos 60 value is 0.5, which means the value is going to be 5 newtons, right? 10 multiplied by 0.5, 5 newtons. And the sine 60, sine 60 is 0.86, okay? Which means 10 multiplied by 0.86, and here this is actually 10 10 sine 60, it is 0.86, so it become 8.6 newtons. And for the horizontal component become 5 newtons, right? Cos 60 is 0.5. Now instead of this 10 newton, what I can do? I can remove that one, and instead of that force, I can use these two forces. I can draw force upward, then I can say the value should be 8.6. And also another force in this direction. And what is that value? 5 newtons. Now, can you find me the resultant force in this force diagram? How to find out the resultant force? You can take these forces into x and y directions, right? If the forces are in the same direction, you can add them. If they are in the opposite direction, you can subtract. So if I only, first of all, I'll consider the x direction, okay? For the x direction, there's a 10, 5, 20, opposite 5. So what is going to be the resultant for the x direction? 10 plus 20 because they are in the same direction. 5 is also in the same direction. So I can say for this side total of 10, 20 plus 5 and the in the opposite direction minus 5, right? So I can write down, okay, 10 plus 20 plus 5 minus, because in this opposite direction, and what is the value? 30 newtons. And in the y direction, I will consider this side is as the plus value. Oh, okay, I forgot to put the value in here, right? I think this, let's take this one as 5. Now in the y direction, positive side it is 8.6, negative side 8.6 minus 5 and minus 25. Yes, am I correct? This is a positive side, negative 5, negative 25. Then I can take final values for these two sides, right? And in the force calculations, we have another technique, right? Once we have this horizontal and vertical component of the force system, you can use a separate equation and find out this resultant force, right? We can directly calculate the resultant force. So I'll do that one in the separate lesson. Now I think you can understand why you have to resolve the forces, right? Because when we are dealing with this type of an angular force, it is very hard for us to take it out as for the calculations, right? That is the issue. Okay. We'll do this example. Right. Now here you can see in the right side figure, there's a trolley like this with the wheels, and it has been moving downwards by its own weight, right? By its own weight in a slope ground, right? In a slope ground or ramp like this. So what are the forces applying dealing with this type of trolley system? What is the free body diagram? First of all, you can draw the weight of this trolley, right? Then from these two sides, actually, there you have the reaction force. Okay, reaction force is perpendicular to the flow. Reaction flow is perpendicular to the flow. So instead of those two reaction forces, I can just draw a force like this. This is the reaction force. And what is the direction of the trolley? Let's say this is moving in this direction. Then what is the friction? Friction is from here to here, right? Now you can see it is also, again, we are at a issue. What is that? So these 1, 2, 3 are in the horizontal and vertical case, but I have to resolve this red colored force. The weight has to be resolved, right? Then how can I resolve that? So I will take another color. I have to resolve this one into two sides like this, right? So in order to do that, what I need kind of an angle here, right? I need one. I need somewhat an angle. Is it be over here or this angle or this angle? However, you have to remember that this ramp angle is actually equal to this angle. If you know the angle of the ramp, it is going to be included in here. If you know the weight, then you know the angle. You can reslow the force, right? Once you reslow the force, what you can do? You can remove this red colored one. Then you can just flow the question as it is. Okay. Now I have a question. The person, you can see the same person. He is pulling a large box using a rope, right? And I need you to understand, use the idea of the components, the vertical and horizontal component of a force to explain why they are more likely to get the box to move if the rope is horizontal, as in A, or than if it is sloping upwards, as in B. Okay. Right. Which one is the easiest one? Is it figure A or figure B? Actually, this should be figure A. Figure, if you apply the force like the person A, it is much easier. Okay. It is much easier to move the box. But if you take the force up to an angle, the reason is that since you are resolving the force, force value become reduced. Right? Force value become reduced. In the earlier example, if you remember, I take 10 newtons, I resolve into two directions. So what are the force values? The 10 newtons become how much? One side is 5 newtons and this side become 8.6 newtons, right? So what is the thing you have to remember here? Now you can see if you are applying a horizontal force, you need only 5 newtons to move this force, right? Move this box actually. But since you are sloping, I mean, you are applying the force with an angle, what happened to the value of the force? It become 10 newtons, right? So it basically become double, right? So what is that exact angle? The exact angle was 60 degrees, right? Which means that if you pull anything in a 60-degree to the horizontal, the value become double. So that is why that is the answer actually, right? That's the answer. You can try to do this question. Okay. A craft, sorry, a crate is sliding down a slope, right? Then I can just start drawing the diagram. So it is like this, sliding down. And let's say this is the crate. Say this is the crate. Okay. The weight of the crate is 500 newtons. Okay. Then weight is this one. Remember, it is not I mean perpendicular to the ground, okay? It is perpendicular to the earth, the weight. So this is 500. The slope angle is 30 degrees with the horizontal, which means this angle is 30, and automatically this angle also become, okay, I forgot to mention one force here. It is the reaction force, right? And since this uh, plate is sloping down, the friction is in this direction, right? Uh, Now we have to remember that if this 30-degree angle, right? If this is 90 degrees, what is the value of this angle? This side. However, it is equal to this side. So basically, this angle become 30 degrees, right? This side become, let me use another color. This angle is 30 degrees. Okay. Then you have to draw a diagram to show the situation, include arrows to represent the weight, it's okay, and the contact force and the slope acting on the plate, okay. And the contact force means the reaction force here, slope acting on the plate, I just put the friction force as well. Calculate the component weight down the slope. What is the component of the weight down the slope? Now you can slow that one down, right? Now, down the slope means this direction. Can you take a component to that side? Yes, of course. You can just take the component like this, right? And again, you can take the weight component into two like this. Then you can find out the values, right? Uh, Now you have to give me the answer for this one. Okay, if this is 30 degrees, now this angle is 30 degrees. What is the value? Oh, is it going to be the sine value or the cos value? 500 for this side, for the answer for the B component of the weight down the slope. Is it a 500 sine 30 or 500 cos 30 to this side? You can put the answer in
Sine.
the box. It is
Sine.
sine,
Sine.
right? Of course. And this side is 500 cos 30, right? Then you can just take out 500 sine 30 and do the answer in newtons. Explain why the contact force of the slope has no component down the slope. Okay, so this is the contact force. And this red colored contact force doesn't have any force applied in this direction. Why is that? Okay, we can basically find that one. So this angle is actually 90 degrees. Okay, you might wonder that, okay, any force, let's say this value is 20 newtons. If you take 20 Newton, 20 cos 90 degrees, so sine 90 degrees, both values are going to be zero. Both values are going to be zero, which means that basically, if there is a horizontal or vertical force, there is no connection if the angle is 90 degrees. There, I cannot take into separate component because it is obviously in a specific direction. දැන් මෙතන y force එක තියෙන දිශාව value එක 20 නම් මම angle එක 90 degree කියලා consider කරොත් ඒ 20 sin 90 and cos 90 values are going to be zero, right? That's the issue. That is the reason. What third force might act to oppose the motion? So this is the motion direction, right? It is sliding down. Uh, what is the opposite of the motion? The friction force. In which direction would it act? It is in the opposite direction, as you can see here, right? Now you can try to solve this question, right? It is the exact, like, it is the same thing, right? A boy of a mass 40 kilograms, the weight is going to be 400. Water slide that the boy is actually water sliding, right? Which means, I mean, in a water slide, it is like less friction. However, they have already mentioned friction as well. So we'll assume that there's a friction, right? So why we apply the water in a slide to reduce the friction, right? And the slope is 30 degrees to the horizontal, right? Horizontal. The friction force up the slope is 120 newtons. Okay. Calculate the boy's acceleration down the slope, which means in the direction of the slide, what is the acceleration? To this side, what is the A value? Right. The second thing we know that if there is acceleration, there should be a moment, right? Then what is the equation we can use? It is F is equal to ma, right? F is equal to ma. We need to find out this A now. Sorry, yes. And you already know the weight of this mass of this boy, 40 kilograms. And now you need to find out what is the force applied in that direction. Force applied in the direction of the sliding boy, right? That is why I have put some arrowhead in the same direction, right? This is the direction. Okay. I cannot put any kind of the other forces, right? Now I cannot consider any forces applied in down, up, right? Like that. For this F equal ma equation, I have to apply the force applied in this direction, which means I only concern about any type of force applied either in this direction or this direction. These two directions. That's it. First, you have to remember that. Right? Okay. Uh, Calculate the work. Okay. Take the acceleration free fall G to be 9.81. Now, this is for the university calculations. We do consider the gravitational acceleration at 9.81. But in this case, we'll take it as just 10 meters per square second. Okay. Okay. So we can draw a free body diagram, right? Right. I need to find out the force now. So I can actually take out this weight component into two separate parts, right? This direction and this direction. And here I have the contact force, or right, friction is also there. And now if you can identify, I only need to find out what is this force value and what is the friction. That is all I need, right? If you know those two, then I can take a resultant force. Okay, resultant force. So we'll just basically go to the values. Okay, so this is 400 newtons now, the weight, right? So if this is 30 degrees, this is also going to be 30 degrees. So this is going to be 400. Right, 400 sine 30. Friction force is 120 newtons. Okay, 400 sine 30, I will calculate that value. Okay, sine 30 is 0.5, which means 400 multiplied by half means it is 200 newtons. Okay. Now, according to your understanding, so boy is moving in this direction, right? So what is the resultant force in this direction? It is 200 minus 120, right? In this side, it is a plus value. If I consider this side is a plus value, plus side, in the opposite side, there's a 120. So the answer is going to be how much? How much force? What is the resultant force?
80.
Yes, 80 newtons in this direction. So now we have the force. Okay, 80 newtons and M is equal to 40. What is the A value? Which means A is going to be 2 ms minus 1 or 2. 2 ms minus 2. This is the answer. It is not much of a case, right? Now, let me show you where the students are actually confusing and trouble having the answer. Right? I think anybody can easily find out this value. Right? Anybody can find out the F. You have to use a F is equal to MA equation. Okay. Anybody can comment on that, but certain people, certain students are actually getting the answers wrong because they are assuming this angle is equal to 30 degrees. That is the first wrong thing. And sometimes they cannot understand what is the cos one, what is the sine one. So if you are taking two different things, again the value is again going to be different. And sometimes once you find out this 400 sine 30, they get the 200 newtons and directly apply the F value as 200. However, there's a friction opposed to that. So that is why we have to always draw the free diagram with all the forces at the same time. Okay. Now, if I actually ask you to find out the, since this is a moving boy, so there should be a kinematic friction, right? The friction is kinematic. Then if I ask you to find out what is the kinematic friction, uh, you can easily find out that one as well, right? What I'm asking is what is the mu k value? So if is equal to mu k r, now what is the r value? R is equal, this is the contact force or reaction force or perpendicular force or normal force. This r is equal to this component, not 400. Now it is equal to 400 cos 30. 400 cos 30, I have to take the value now. Cos 30 is 0.86. Okay. Then 0.86 multiplied by 400 means 344. So this value is 344. This is equal to R value. Why it is equal to R? Because it is not, the object is moving in this direction, not in this direction. Which means in for this direction it is stable or in equilibrium. So R value is going to be 344. My next question, what is the F value? Can you give me an answer? What is the F value? Is equal to. Is it 120 or is it 200 or is it 80 newtons? You have three choices.
120.
Yes, because this is a friction force, right? Not the resultant force. That is also one confusing point. So you can just put 120 here, take out the mu k, and it should be some kind of a 0 point value. It's very easy as it is, right? So this is the type of questions we can, actually this is the weight of the question we can ask in the A-level exam. It's not much of an issue, right? Not an issue at all. So in this is the answer. Actually, they have considered instead of 10 as a G value, they consider as a 9.81, which is more accurate. So they get the resultant force, we take it as 80. They have considered just 76. It's a small thing. Okay, I forgot. Okay, for the acceleration is 1.9. I just take the answer as 2, right? It is more near value. Mhm. Okay, right. Next page. So that's for today actually. Here are some application of Newton's law questions with the answers. Uh, right. Uh, for the first one, they have just given the mass and the acceleration, asking the what is the required force. It is F is equal to ma, right? You can see it is very simple, just a one force, right? Second one, a mass is given, a velocity is given, right? With the time. So if there's a velocity with the time, we can find out the acceleration, right? Then what they're asking what is the force. So if is equal to ma, and you have to find out the acceleration in this case, since it is actually a deceleration, right? Because they are moving in this much of 80 kilometers per hour velocity, but it is stopped. So which means the final velocity is going to be 0. So 0 minus 22 means you have to convert this kilometers per hour into ms minus 1, because this is the SI unit for velocity. So that 22 is applied in here with the velocity. Since it is a deceleration, the acceleration value is minus 2. Right? It doesn't matter. And since you already find out the A, you can apply F is equal to ma. M is 1500, value is 300 newtons. Minus means to stop this vehicle. These are also a similar question actually, right? In this case also they are asking for acceleration, right? Which means that there's a crate on the floor, there's a friction in this side, which means we are moving the object in this direction, right? However, it is not a horizontal force, it is a angled force like this P. First of all, uh, you have to convert this force into horizontal component, right? And then you can apply the F is equal to ma in this direction. So if you are considering about this direction, you have to only concern about this force and this friction, right? And you can see P cos 60 minus F naught means the friction, because it is in the opposite direction. And basically the weight is already given. So you can find out the mass. And the acceleration is 1 ms minus 2. It's kind of an easy one, right? Right. In the next week, we will talk about talking to several other parts as well, right? For example, we can discuss about the equilibrium of forces, right?